Let's recollect the properties which we have already seen. What is the first property we have seen?
Linearity.
The first property is linearity property. Okay. So as per the linearity property, so one function x1 of t whose Laplace transform is x1 of s with ROC some R1 in the S plane, and x2 of t Laplace transform represented with x2 of s with ROC R2, then some scalar quantity a1 multiplied with x1, there is a2 into x2. The expected Laplace transform will be a1 x1 of s plus a2 x2 of s. And what is ROC? What is ROC here?
R1 intersection R2.
Don't specifically say R1 intersection R2. Mention ROC contains R1 intersection R2. Okay, the new ROC contains R1 intersection R2.
Yes, sir.
This is the first property. What is the second property we have seen?
Time shifting property.
Nice. Time shifting. This is a recollection of the physical class. So if x of t, a continuous function, Laplace transform represented with x of s with ROC R, some region R in the S plane, then x of t minus some constant shift t naught, Laplace transform will be e power of minus st naught into x of s. And what will be the ROC? What will be the ROC for this case?
R.
R.
Right. With ROC, the same R. Why it is same R? It is same R because anyone can tell me?
There is no change in poles.
Yes. So multiplying with this e power of minus st naught is representing only the phase function being multiplied. So no new poles are being added to the x of s, or no old poles have been eliminated from the x of s. That's why the ROC will become the same R. Yes. What is the next property we have seen in the class?
Time scaling property, sir.
Nice. Time scale. So if x of t Laplace transform represented with x of s with ROC R, then x of some scaling factor multiplied with t inside the x function. What is the Laplace transform for this?
1 by mod A x of s by a.
1 by mod A x of s by a.
Nice. 1 by mod a x of s y. And what is the new ROC?
AR.
Nice. It is a into r. And in this, we have seen 4 cases. First one, a greater than 1. Second case, a lying in between 0 and 1. Third case, a lying in between minus 1 and 0. And fourth case, a is less than minus 1. Can you please tell me what happens to ROC in these 4 cases, one by one?
There is
The first
expansion.
is expansion.
Yeah, you see the expansion in the ROC, right? Next one.
Compression.
right? Then
Compression and reversal.
right, compression and reversal of the limits of RBC. Then
Expansion and reversal.
right, expansion and reversal of limits of the RBC. Right. Okay. And from this time scaling property, by substituting A equal to 1, we deduce the time reversal. Am I right?
Yes, sir.
Okay. Time reversal, you can write A x of t, Laplace transform is x of s, with ROC some region R base plane, then x of minus t, Laplace transform will be 1 by mod A leads to 1, x of minus x of s by A, so you get x of minus s. What is ROC? What is ROC?
Sir, we have not completed time reversal, sir.
No. Just I discussed this actually, but it's okay. Just see the time scaling property in this. In place of A, replace with minus 1. You will get x of minus t. Then 1 by mod minus 1 will be 1. X of s by minus 1 will lead to x of minus s. And then ROC is A into R. And in place of A, we will be replacing with minus 1. This is how you will get. Now tell me what will be the ROC here in this case?
Minus R.
Minus R.
Minus R. Now tell me what happens to the ROC now? What is the comment on the ROC now here in this case? By seeing this minus R, what happens to ROC? It is only
Reversal of limits.
reversal of limits of ROC. That's it. Did you understand this reversal of limits of ROC? Or I'll quote an example. For suppose if the ROC lies in between minus 2 and 3, for suppose. If this is your R, then what happens to minus R? What happens to minus R?
It lies between minus 3 to 2.
Right. It lies in between minus 3 and 2. So this becomes the new ROC. Understood?
Yes,
Just
sir.
multiplying the entire range of sigma with minus. That will give the new range for the sigma. That is from minus 3 to 2. Okay. I have given some properties to do on your own. What are those properties?
Uh, Time differentiation, differentiation in S domain, and time convolution, sir.
I think we have also seen shifting in
Shifting in S domain.
S domain, right? So that will also highlight.
Yes, sir.
So next property is shifting in S domain. This also we will recollect and then we go for limits. So the statement, if x of t Laplace transform is x of s with ROC R, then so shifting in S domain is what we see the shifting property that can be applied in the other side. And the time function, can anyone tell me what is the time function? This we already did in the classroom.
X of t into e power s naught into t.
E power of s naught t into x of t. Nice, good. And what is the ROC?
R plus real part of S naught, sir.
Right. It is the old R plus real part of S naught, because S naught is a complex constant. We have to consider only the sigma naught in this case, since ROC depends only on the value of sigma. So I think these are the properties we have seen in the classroom, and some properties I have given to work at home. And the first one, the property I have given is time differentiation property. Right. So statement, if x of t has a Laplace transform x of plus with ROC R, then now tell me what is this time differentiation means. What should I do now?
D by dt of x of t.
Right. So I have to perform the time differentiation for x of t, and then what should be the Laplace transform? This you have to fill up. So we already derived the inverse Laplace transform. Do you remember that?
Yes, sir.
Yeah. So please write the inverse Laplace transform formula and differentiate it on both sides. Please do it. I'll also do on the screen. Inverse Laplace transform formula. Can anyone recollect inverse Laplace transform formula?
L inverse of x of
Right? L inverse of x of s is equal to
equals to
x
1 by 2 pi j
1 by 2 pi j integral,
integral sigma minus j infinity to sigma plus j infinity
right?
x of s into e power st ds.
Right. Okay. So we have the inverse Laplace transform formula now, and here we have to perform time differentiation. So you have to perform the time differentiation for x of t. So since we have the x of t expression in the form of inverse Laplace transform, so let's go for applying the time differentiation on both sides for this inverse Laplace transform formula. So when you apply the time differentiation, you observe that this is a constant. X of s is independent of t. ds is also independent of t. So only e power of st is a quantity which depends on t. So when I differentiate this on both sides, so that differentiation will be applied only on e power of st. Okay. So please try to do it. I'll also do along with you in parallel. So applying the differentiation on both sides. So d by dt x of t is equal to, you write like this first, d by dt of 1 by 2 pi j integral sigma minus j infinite sigma plus j infinite x of s e power of st ds. Now we have two operations. One is differentiation. Inside it we have integration. So how to simplify it? How to simplify it?
Interchange the order of operation.
Right, interchanging the order of operations. So integration comes out and differentiation goes in. So 1 by 2 pi j integral sigma minus j infinite sigma plus j infinite. I can also take x of s along with the integral, and now I perform d by dt of e power of st, because e power of st is the only function which is depending on t. That's why d by dt is applied only for e power of st. Yes? Tell me now. 1 by 2 pi j, the same limits, x of s. What is d by dt of e power of st?
S
e
into
power
e power
st
st.
into s.
S into e power of st ds. Okay. Now I cannot take this s or e power of st out. So I am going to have a proper grouping for that. Sigma minus j infinite, sigma plus j infinite. On left hand side it is d by dt x of t, and I am going to group like this: s into x of s, e power of st ds. Now the result is by comparing with the original formula of inverse Laplace transform. So for your convenience, what I am doing is I am rewriting this. So just rewriting the inverse Laplace transform formula. X of t is equal to 1 by 2 pi j sigma minus j infinite sigma plus j infinite x of s e power of st ds. Now, if so, as per the statement, you can see here x of s is a Laplace transform of x of t. So please compare these two now. X of s is a Laplace transform of x of t. Now tell me, what is the Laplace transform of d by dt x of t?
S into x of s.
S into x of s.
Okay. So the Laplace transform of d by dt x of t by comparison will become, because 1 by 2 pi j is same, the integral is same with the limits, e power of st is same, ds is same. So the only change we observe is s into x of s. Okay. So therefore, what I should write here, the Laplace transform of d by dt x of t will be s into x of s. So already you have x of s, it will be multiplied with s. Now, can anyone tell me what will be the change in ROC? Any change in ROC? Shall we go for one example?
Yes, sir.
Right. Now we give two examples. Okay. Example one. Let us take x of t is the well-known function e power of minus 2t u of t. Okay. Now tell me, what is its ROC?
1 by s plus 2.
Laplace transform is 1 by s plus 2. You told Laplace transform. ROC?
Okay. Sigma greater than minus 2.
Nice. Sigma greater than minus 2 is the ROC. Okay. Good. Now, uh, if I perform d by dt x of t for this function, then as per the property, the Laplace transform should be s into x of s. Okay. Now, what will be the s into x of s here? S into x of s, if I perform as per the property, what we will have the result?
S by s plus 2.
Okay. Now, do you think that any new pole is introduced into the x of s?
No, sir.
No, sir.
No. Or any older pole is being cancelled?
No, sir.
No. That means the ROC remains the same. Got it?
Yes, sir.
Now, so don't come into the conclusion now. Okay. So we'll go for another example, because you cannot directly write by seeing only one example. You cannot directly write that ROC is the same, right? So I'll give you one more example. x of t equal to, let us say, u of t. Now, please tell me what is the Laplace transform of u of t?
1 by s.
1 by s. And what is the ROC?
Sigma greater than 0.
Nice. Sigma greater than 0. Very good. Now, as per the time differentiation property, if I perform s into x of s, what is happening here?
S and s gets cancelled out and it's constant 1.
Right. S into 1 by s. You observe that this s and s will get cancelled and it leads to 1. Then what is the ROC in this case?
Entire S plane.
Entire s plane.
Right. When it is a constant, then it is entire s plane. Now, I have given one example where there is no change in the poles. New poles were not introduced or old poles were not cancelled. ROC remained the same R in this case. I have shown you one more example where no new poles were introduced into the X of S, but already existing pole at origin S equal to 0 is being cancelled because of the new 0, where the ROC has changed here now. Earlier case, the ROC is not changed. Now this case, earlier is changed, the ROC is changed. Now can you please tell me like what can be the ROC that I can write? So first example, ROC not changed, so I'm not commenting on it. I'll do one thing. I'll draw the first ROC for this. I'll draw the ROC. Sigma axis, j omega axis, S plane, and ROC is sigma greater than 0. So sigma greater than 0 means, so here it is. This is the line sigma equal to 0. Sigma greater than 0 means, am I right? What I am drawing?
Yes, sir.
Right. So this is your R. Okay. Now what I am doing is now d by dt u of t as per the differentiation. Laplace transform will be s into 1 by s, which is leading to a value of 1, where the ROC is entire S plane. Okay, so sigma axis, j omega axis, this is the S plane. Now the ROC is entire S plane. Am I right?
Yes, sir.
Right. Now, does this new ROC contains the old R?
Yes, sir. It does.
Right? So new ROC contains, this is the old ROC, right? That is R. Okay. Now the new ROC is the entire S plane, but it contains the old R. So what can we write here for the ROC? Here, what can I write? With ROC containing R. Got my point? New ROC contains the old R. This is what I want to convey. New ROC here is represented with green. Old ROC is represented with red. So this new ROC contains the old R. That is what I wrote here. New ROC contains the R. Got it?
Yes, sir.
What is the next property I have given you?
Differentiation in S domain.
Right. differentiation in S domain. Right. Now write the statement. If x of t, Laplace transform represented with x of s with r is r. What should I write? Now, differentiation in S domain means,
d by ds of x of s.
so now differentiation is being performed not in time domain but with x of s. So solving this needs only the recollection of the Laplace transform formula in finite limits x of t e power of minus s t dt. So all, if you didn't do this, just write the Laplace transform. This is the Laplace transform formula. And since the property contains differentiation with respect to s for this x of s, so please go for differentiating the Laplace transform formula on both sides. That's it. D by dt of, sorry, not d by dt, it is d by ds. D by ds of x of s, d by ds of this integral. Integral in x of t e power of minus s t dt. Okay. Now, how can I simplify it?
Interchanging the order of operations.
Yes, same as usual. Interchanging the order of operations. Integral comes out along with x of t because it is independent of s. And the differentiation d by ds will be applied only on the function e power of minus st. Now differentiating that with respect to s, tell me. What do you get? Differentiating with respect to s.
Minus t e power minus s t.
Right.
Minus t e power minus s t.
Minus t into e power of minus st will be the result after differentiating with respect to s, that e power of minus st. Now can I take this t out of the integral?
No, sir.
No, you can't take it. Right. So what I do, I'll group them properly. So minus t into x of t, I'll group it. Integral will remain the same, e power of minus st dt. Okay. Now, just I want to rewrite this again by just removing that minus and taking that onto the other side, like multiplying with minus on both sides. We get minus t by ds x of s equal to infinite limits for the integral t into x of, just I am taking out minus e power of minus st ds. Sorry, dt. Now result is by comparison. So x of s is integral infinite limits x of t e power of minus st dt. Now if x of s is a Laplace transform for x of t, then what is the Laplace transform for t into x of t? It is minus d by ds into x of s. So a small change I want to make in the statement, like I want to introduce a minus. And what should I write on the left hand side, time domain side?
t into x of t.
So t into x of t now becomes the function with ROC. Can anyone have a guess and what happens to the ROC? Tell me yes or no. I'll give you an example. Then you can tell me later. Shall I give an example? Obviously, I'll give an example.
Yes, sir.
Let's go for an example. Now, let's take the same one function e power minus a2 of t. Laplace transform will be 1 by s plus 2 with RC sigma greater than minus 2. I'm directly writing because you all know this. Okay. Now, what I have to do as per the differentiation in S domain, what I have to do? What I have to perform for this x of s? What I have to do?
Differentiation.
Yes. So already you have here x of s in this example, right? Now let's differentiate that x of s with respect to s. Minus doesn't matter. I'll also add minus for that. So what I'm doing is minus d by ds x of s. That means what I did for the time domain function, the time domain function is t into x of t. That means t into e power of minus 2t into u of t. This was happened in time domain. Now its equivalent S domain is minus d by ds x of s. So minus d by ds of, what is x of s here in this example?
minus 1 by s plus 2 whole square.
Right. The answer will be minus 1 by s plus 2 whole square. Is it minus 1 by s plus 2 whole square or plus 1 by s plus 2 whole square?
Plus, minus
You'll get plus.
and minus gets plus.
It gets plus. So what has happened? Tell me what has happened. Earlier, how many poles you have? Earlier, in this case, how
We
many
had only
poles you have?
one pole only.
We have one.
One pole, sir.
Right? Nice. Now here, after differentiating this as per the property, how many poles you have?
The same pole, but it's a square, so
Exactly. Now you have two poles, but what is happening here? Two poles at the same location. Am I right?
yes, sir.
Now, if you have two poles at the same location, do you think that ROC changes? No,
No,
right? So s
so
plus
it's
2
the
whole square in
same.
the sense it is 1 by s
No,
plus 2
sir.
into 1 by s plus 2. Okay, so I'll make you understand clearly. So this can be written as 1 by s plus 2 into 1 by s plus 2. Am I right? Then later you can represent that in the form of a partial fractions even. And that leads to 1 by s plus 2 whole square. Right. So here what we do is, for this, the Laplace transform will be sigma greater than minus 2. For this, the ROC will be sigma greater than minus 2. What is the intersection between these two? It is the same, no?
Yes, sir.
So ROC will be the same. Okay. So what should I write here with ROC? What should I write here?
R.
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 Right. Super. Okay. So ROC doesn't change in differentiation estimate. Now, what next property I told you to do?
Time convolution.
Convolution.
Time convolution. Right. Okay. So convolution needs minimum of two signals. So I'm writing the statement x1 of t Laplace transform represented with x1 of s with ROC R1 some region 1 and x2 of t Laplace transform x2 of s with ROC 1 2 then x1 of t convolution x2 of t Laplace transform will be, and directly writing the answer, multiplication between the S domain functions with ROC. This we will write later. First, let us prove this property. Now, can anyone tell me the convolution formula? X1 of t convolution x2 of t.
Integral over infinite limits x1 of t minus tau into x2 of tau d tau.
Okay, anything you can write. X1 of tau into x2 of t minus tau you can write, or you can write x1 of x2 of t tau into x1 of t minus tau. Anything you can write, okay? Because it satisfies property. So I wrote the general formula, right? X1 convolution x2. Now what I have to do? I have to apply the Laplace transform. So Laplace transform of this convolution x1 convolution x2 will be, now applying the formula of Laplace transform, integral, it is x1 of t convolution x2 of t. I'm not changing any formula, check here, just substitution was done. Now replacing that with its formula, this remains as it is, and now Laplace transform formula comes inside the convolution formula. So x1 of tau, x2 of t minus tau, d tau, substitution done. So for this is the entire substitution done, and the formula is written as usual. And for you have two operations. Now the operations are two integrals, just interchanging the order of operations. So the convolution integral comes out along with x1 of tau. I can take it, and the Laplace transform goes x1 of t minus tau e power of minus st dt comes in and d tau goes out. Is it clear at this point?
Yes, sir.
Yes, sir.
Now, anyone tell me, seeing this, what property of Laplace transform can you apply? Is this representing time shift?
Time shift. Yes, sir.
Okay. Now, directly apply the time shift property and tell me the result. What is the shift here?
Tau.
Right. So, please see the time shifting property and tell me what will be the simplification of this inside integral.
E power minus s tau into x of s.
E power of minus s into x2 of s. Okay. Because
Okay.
the
Yes,
function
sir.
is x2, you will be writing x2 of s. Right. And remaining all as usual, you can write integral infinite limits x1 of tau d tau. Now, can I take this x2 of s out of the integral now?
Yes, sir.
Yes, it is. Because it is independent of tau, you can take it out of the integral. So x2 of s comes out. x2 of s comes out. And the remaining integral I am writing as usual. x1 of tau e power of minus s tau d tau. Now see this, is it resembling the Laplace transform property plus formula of x1?
Yes, x1
Yes,
of
sir.
s.
Now this becomes x1 of s. So therefore, the answer will be x1 of s multiplied with x2 of s. So Laplace transform of x1 of t convolution x2 of t lead to x1 of s multiplied with x2 of s. Clear?
Yes, sir.
Right. Now, any idea of how can I interpret the new ROC?
So is it R1 intersection R2?
It is partially correct. Okay. You have to write it ROC containing R1 intersection R2. Okay. The new ROC, the new ROC containing the old R1 intersection R2. Got it? Sometimes the ROC will be directly R1 intersection R2. Sometimes the ROC will be, it contains R1 intersection R2. I will give you an example, best example I will give you. Okay. Now see. Let me take an example. x1 of s is s plus 1 by s plus 2. Let's don't bother about what is x of t. Can you please tell me, assuming that the x1 of t is right sided, can you please tell me what is the ROC in this case? That is R1. Assume that the signal is right sided. Tell me what is R1?
Sigma greater than minus 2.
Right. So I directly said that it is right sided. Sigma greater than minus 2 will become the ROC. Great. Now I will give you one more example. Here also I am taking an assumption that x2 of t is right sided. Here x1 of t is right sided. Here x2 of t is right sided. Now tell me what is the ROC R2 in this case?
Sigma greater than minus 1.
Okay, great. So for the first function, assuming x1 is right sided, sigma greater than minus 2 is the ROC. For the second function x2 of t, it is s plus 2 by s plus 1. The ROC R2 is sigma greater than minus 1. Now, as per the convolution property, what I have to do here? What I have to do?
x1 of s into x2 of s.
Nice. The product of x1 and x2. So x1 of s into x2 of s. So that means s plus 1 by s plus 2 multiplied with s plus 2 by s plus 1. Tell me what happened?
It is constant 1.
Yeah. Now here s plus 1 is a pole, but here s plus 1 is 0. So pole 0 cancellation occurred. Okay. And in this case, s plus 2 is a 0, whereas s plus 2 here in this case is a pole. So multiplying these two, what happened? Pole 0 cancellation has occurred and it resulted a value of a constant 1. Now, in case the Laplace transform is a constant, what will be the ROC?
Entire s plane.
Entire S plane.
Entire spin, right? Good. So ROC here is entire spin. Is entire spin. Now, what I do is I will plot R1 intersection R2. What is R1? What is R1?
Sigma greater than minus 2.
Sigma greater than minus 2. Sigma greater than minus 2. R2 is sigma greater than minus 1. So sigma -1 -2, I will mark here, -1 here, -2 here. Now what will be R1 intersection R2? Can anyone tell me?
Lies between -2 and -1.
Check once your
Oh,
answer.
intersect. Okay, yes. -1 to the entire positive.
Right. So earlier it was right greater than R1 is
Yes.
greater than -2. Next, with respect to the other function, it is, am I right? Just to differentiate, I'm drawing it down. So now tell me, what is the common ROC?
Minus sigma equal to -1 to infinity.
Yeah, it is sigma greater
Greater
than
than 1.
-1. Okay. Now,
Yes, sir.
right. So as per the general example, it is R1 intersection R2 here is representing sigma greater than -1. Okay. But in this example, which I have told you, this is a special example where pole zero cancellation is occurred. And what is the new ROC here?
Entire S plane.
Now, does this entire S plane contains this R1 intersection R2?
Yes, sir.
Yes. So that's the reason we are writing here. The new ROC contains R1 intersection R2. Okay.
Yes, sir.
Right. Now, maybe you have one more doubt. So when this ROC can be written as only R1 intersection R2, I'll tell you one more example. X1 of S equal to S by S plus 1, and ROC here is sigma greater than -1. Assume X1 of T is right sided, and X2 of S is 1 by S plus 2. ROC is sigma greater than -2. Assuming that X2 is right sided. Now tell me, what is the ROC in this case? X1 of S multiplied with X2 of S. If I do you observe any pole zero cancellation?
No, sir.
No, right? Now in this case, the new ROC will be R1
Sigma
intersection R2.
greater.
It is clear. Okay.
Yes, sir.
So
Yes,
in
sir.
such examples where you don't have any pole zero cancellations, then it will be R1 intersection R2. In special cases like this, sometimes we may observe some pole zero cancellations. That's the reason we write here not directly as R1 intersection R2, but we write here ROC contains R1 intersection R2. Is this clear now?
Yes,
Is it
sir.
okay? Right. Property number, property 8. Ninth property. Can you do conjugation property? Or shall we go for the time integration? Because we did the differentiation. We'll go for this. Okay. Now this is very similar to the property which we did in Fourier transform. So if x of t, Laplace transform represented with x of s, with ROC R, then please see the property in Fourier transform minus infinity. That means past to present x of tau d tau Laplace transform will be. I'll write this later once you do. Can you do? Okay, what is the idea to do this?
By integrating the inverse Laplace transform formula.
First you have to do is write the inverse Laplace transform formula. But here you don't see here you don't see x of t, x of tau, no. So first write the inverse Laplace transform formula and then rewrite that with x of in terms of x of tau. Do it along with me. Write the inverse Laplace transform formula. So it is x of t equal to 1 by 2 pi j integral sigma minus j infinite sigma plus j infinite x of s e power of st ds. Then since here in the property you have x of tau here, so please write this in terms of x of tau equal to 1 by 2 pi j. Wherever you have t, replace with tau. Sigma minus j infinite, sigma plus j infinite, x of s e power of s tau ds. Now perform the integral. Next, what I have to do? Am I audible to all?
Yes, sir.
Okay, yes, I got it. So this integral minus infinity to is applied on data comes in and ds goes out. Now please go for integration 1 by 2 by j sigma minus j sigma plus j. So any result for this? Any result for this?
E power st by s.
Right. E power of st by s will get. Any doubt in this, or should I go for doing the integration for this? Integrate this, you will get e power of s tau by s. Apply the limits, it is clear. That it is e power of st by s. Shall I proceed?
Yes, sir.
Yeah. Now grouping will be done like this: 1 by s into x of e power of st ds. And here you have minus infinity x of tau 2. Result is by comparison. So I am rewriting the formula of inverse Laplace transform. Sigma minus j infinite, sigma plus j infinite, x of s, e power of st ds, and here we have x of t. Now x of s, x of t, the Laplace transform is x of s. Then the Laplace transform of this integral is 1 by s into x of s. Is this clear?
Yes, sir.
So here, this part I'm writing it as 1 by s into x of s. Can anyone tell me? ROC? ROC? Again, you need an example now, I hope. So let x of s, I'm taking it as 1 by s plus 2. Now what we are doing here? What we are doing here?
Multiplying it with 1 by s.
1 by s. So 1 by s into x of s leads to 1 by s into s plus 2. Now tell me what happened?
Another pole is added.
Right. So earlier it was sigma greater than minus 2 if right-sided is assumed. Now here what happened? A new pole, we have only one pole earlier at so one pole
Origin.
at s equal to minus 2. Now here new pole is introduced into the transfer function of x of s, what is and it is the origin. Or you have pole to pole, which is at s equal to minus 2. Earlier we have only one pole, but after this 1 by s into x of s, you have a new pole that is introduced. So you have two poles now. One is at the origin, one is at the same old location minus 2. Now earlier it was sigma greater than minus 2 the ROC. What is the ROC now?
Still sigma greater than minus 2.
It will be an
No,
intersection.
sigma greater than. Yes, sir. Sigma greater
It
than
will be an
0.
intersection, right? So for
Yes,
this
sir.
case, sigma greater than 0 will be the ROC. For this case, sigma greater than minus 2 will be the ROC. Then after partial fractions, you will get it is represented as the intersection of. Can you see this?
Yes, sir.
Okay. So what can I write here is the new ROC contains R intersection sigma greater than 0. Is it clear?
Yes, sir.
R means this one, the old R. Got it?
Yes, sir.
Right. So tell me what should I write here now? What should I write here? This part. R intersection sigma greater than 0. Or you can even write R intersection real part of plus is greater than 0. Okay?
Yes, sir.
Right. We'll go for conjugation property. What is the time now? Oh, it's already 12:06. I hope I started 1 hour back. So then I'll close this today. We have conjugation property. Maybe I can give you this as a homework. What is the property number?
10.
10.
10. Nice. So please try this at home. That is conjugation property. I will give the statement for you. So if x of t Laplace transform is x of s with ROC representing some region R in the S plane, then x conjugate of t. What will be the Laplace transform after finding the Laplace transform for x of t? I mean, the conjugation with of t with some ROC. So you have two question marks to be filled. So x of t, Laplace transform is x of s with ROC R. Then what is the Laplace transform of x conjugate of t? And you are supposed to find even what will be the change in the ROC. So this is the test or homework that you have. Clear my question?
Yes, sir.
Sir.